Welcome. Let's talk about STEM. There is much talk about STEM and the STEM methodology or approach. Some persons are intrigued at the idea of more fully engaging students in the learning process, while others still believe that as the lecturer, they should be the sage on the stage. And still, you will hear people say that STEM is just not new. The acronym STEM is represented as science, technology, engineering or the engineering process, and mathematics. STEM is also written as STEAM, where the A represents arts. Many STEM advocates will tell you that the arts is integral in the delivery of education using the STEM methodology. STEM education is the intentional integration of science, technology, engineering, and mathematics, and their associated practices to create a student-centered learning environment in which students investigate and engineer solutions to problems and construct evidence-based explanations of real-world phenomena with a focus on a student's social, emotional, physical, and academic needs through shared contributions of schools, families, and community partners. Now that was a mouthful. Let's take a few seconds to reflect on what was said. I have highlighted some words or phrases that I believe are integral for us to understand what is meant by STEM education. STEM education may be seen as a range of integration and application. You may have a maths class by itself, or a maths class that includes the use of technology, the use of science, and/or the use of the engineering process. STEM programs are quantified based on the following ranges: STEM 1.0 or 1.0, STEM 2.0, STEM 3.0, and STEM 4.0. STEM 1.0 looks at each individual component of STEM. So you have a science class, just one thing will be done, or an engineering class, just one aspect of the STEM range is being used. The other STEM ranges are STEM Discipline 2.0, STEM Disciplines 3.0, and STEM Disciplines 4.0. In STEM Disciplines 2.0, we have two of the STEM items being integrated. Could be technology and engineering, or maths and science. In STEM 3.0, we have any three of the disciplines being integrated, and in STEM 4.0, we have all four components integrated. Here at the VTDI, a STEM Disciplines 2.0 class might look like a math class where the math lecturer decided to upload his or her course materials to Moodle, Moodle being the technology. The students will have access to the materials that are there. Now that will be maths and technology integrated, STEM Disciplines 2.0. STEM Disciplines 3.0, a beauty service class might be assigned to research the different types of hair and the different types of hair treatment that exist. This they will do using the technology, the computer, the internet, and so on. And then they will now use this information to treat someone who has damaged hair. That would be STEM Discipline 3.0. STEM Disciplines 4.0, where all four categories are integrated, could be used in a theory class, whether it be an education theory class or a career development theory class. Students will be assigned to read up and or research the literature on the different theories that exist. Of course, they will use technology, the internet, online databases, online journals to find this information. The research process, they will then put this information together to answer questions about how the theories could be applied in their class as educators or in their career counseling sessions. They could also now include some maths in this by taking the information, whatever they learned in the research, and use that information to tell us what statistics say about the usefulness and or effectiveness of the theories in different school types or in different cultures. Here at the VTDI, like many other teacher training institutions, the ministry has mandated us to create a STEM integration plan. Now we will take a brief look at that STEM integration plan. The STEM integration plan focuses on 6 main areas. These areas are learner-centeredness, curriculum drivers, STEM or STEAM integration, project-based learning, student-centered assessment, and practicum. For each of these areas, the institutions will need to look at what exists, what is our current situation, what are the necessary changes and or improvements that we need to put in place, and we will also look at the change process, which will take into consideration things like timelines and the members of the team who are responsible for each of these activities. Learner-centeredness. This is where we look at less of ourselves as lecturers and educators and more of the students. Here at the VTDI, we actively engage in CBET, the CBET philosophy and methodology in curriculum, development, delivery, and assessment takes the student at the center of all that we do. Our lessons are encouraged to be interactive and collaborative. A couple of the ways that we plan to improve this student-centered learning environment is to focus on getting more standardized online learning styles inventory system. Another planned item was the use of the Student Advisement Center. Now, as some of you are aware, this Student Advisement Center was established earlier in the month of March. The next area of focus is curriculum drivers. What is it that drives the curriculum? Who are the persons or what aspects of our environment influence what we teach? The VTDI curriculum drivers are related to what the Ministry of Education dictates for us to teach, what the Heart Trust NTA focuses on, what the industry is saying currently, and also what the labor market information is about. Now, we believe at the VTDI that those things are very integral to our teaching and learning process, and therefore these are our main curriculum drivers, and we do not see the need to change that. STEM-STEAM integration. This is readily reflected in the CBET philosophy and methodology that is practiced here at the VTDI. How do we intend to improve this? Well, our current focus looks at how can we upgrade our labs, our workshops and training sessions? How can we incorporate more of the STEM methodology in our training and delivery process? And we want to include or integrate STEM in the non-technical courses. The fourth area of focus is project-based learning. Project-based learning will seek to incorporate the 4 C's of the 21st century skills. Our learners are expected to be critical thinkers, communicators, collaborators, and creators. This, of course, will be demonstrated during the engineering design process, where as team members they will work on solutions for the problems that they have to define. From these solutions they will make models, they'll be able to test the models, and then they'll be able to reflect on these models that they created and redesign where necessary. The final product that they have completed, the project, will be displayed. Students will be able to showcase the work that they have engaged in. They will also be able to reflect on this work, and their classmates will also be able to give feedback on this work. The lecturer will also provide feedback, and the community at large may be invited in to view the work and also provide feedback. Now, feedback is the 5th student area of focus. Student-centered assessment. Here at the VTDI, we focus on authentic assessment, strategies that reflect on what the students are doing and what their peers are doing. Examples of these include projects, journals, and portfolios, among many other things. Still not clear on what this aspect includes? Let's watch this video entitled Jeopardy, uploaded by Jobs for the Future, that outlines some points about student-centered self and peer assessment.
Welcome back to Students at the Center Week on Jeopardy! Bill, you have command of the board.
Let's do student-centered assessment for 200.
A formative assessment method backed by extensive research in which students provide each other with feedback on their schoolwork in order to deepen learning and increase achievement. Yes, Jody?
What is self-assessment?
No, I'm sorry, Jody. That would be a process of having students identify strengths and weaknesses in their own work in order to revise and improve it. Yes, Bill?
What is a group project?
No, Bill. A group project is collaborative effort in which students define roles and team up to develop an academic project. Anyone? Anyone? Marcia?
What is peer assessment?
Peer assessment, that is correct. Feedback and revision are essential to learning. Research demonstrates that both the student giving and the student receiving the feedback can deepen their level of learning and raise their level of achievement.
Interesting. I'll take student-centered assessment for 400.
The Daily Double!
I'll wager it all, Alex.
Wow, okay. Very good. Here it is. These must be clearly defined and communicated and grounded in the content area or discipline in order for formative assessment to be effective.
What are criteria and standards?
That is correct. You choose again, Marcia.
I'll take student-centered assessment for 600.
This tool for offering critique promotes effective peer feedback between students and includes steps such as ask clarifying questions and make suggestions.
What is the ladder of feedback?
Yes, Marcia, you're on a roll.
Assessment for 800, Alex.
Excellent. At the end of self or peer assessment, it is crucial to allow time for this process so students can incorporate feedback and improve their work.
What is revision?
Yes, Marcia, you've mastered the category. It is also important for the teacher to provide continuous monitoring and guidance during both self and peer assessment. That brings us to our final Jeopardy question. The category, useful resources. Here's the clue. This website offers current research on key components of student-centered approaches to learning, along with a collection of student-centered tools and resources. Let's see how you did. Jody, you wrote studentsatthecenter.org. That's correct. Bill, what website did you choose? Students at the Center as well. And Marcia, did you come up with studentsatthecenter.org? Yes. And with that, Marcia, you're our new champion.
The final area of focus is practicum. Practicum, as we know it, is where it all comes together. The Ministry of Education wants us to prepare for practicum from day one, integrating theory into practice. It's not an end product, it's a process. The VTDI continues to include practicum in the different areas that we teach here. We have areas such as industrial attachment, students do internship and externship, and of course there's teaching practice and observation. How do we intend to improve on these? Well, we want to focus on the evaluation of our practicum activities and also on the capacitating of our practicum assessors to include STEM integration in their assessment. Thank you for joining us here at the VTDI, and may your classes continue to reflect STEM integration as we collaborate to enhance the teaching and learning process.